Today we will see a generalized method to find in which type of feedback an op-amp is. So op-amp falls under a category of amplifiers which are called differential amplifiers. So we have already you must be knowing that normal op-amp is like this. So the reason it is called differential amplifier is because it amplifies the difference between the two terminals of an op-amp. So op-amp has two terminals, which is positive terminal and a negative terminal, and the gain of an op-amp, which is signified by A, is the output voltage is given by the gain times the difference between the input positive terminal and the negative terminal. So this is how a norm op amp in a normal way works. So when feedback is applied, the dimensions or like the how the working of the op amp is changed. So we will now see how which type of we will now see how to determine which type of feedback the op amp is in, and we will then see in a following subsequent video how it affects the operation of the op amp from a normal conventional one. Okay, so we are seeing a diagram like this, which we have an op amp connected in some kind of feedback, some linear circuit. We don't know that there might be resistors, some capacitors, some resistors, some inductors, something. So there is a circuit, and it might be also MOSFETs, and also because MOSFET is in a small signal model, MOSFET is also a linear circuit. So in the bias point, at the bias point V bias, we categorize a MOSFET as a linear circuit, although in a normal working normal large signal model, MOSFET is considered as a non-linear element. So in this the feedback network consists of some linear elements. Of course, it might be a small signal model or a large signal model. We are considering it as a generalized linear circuit which is present in the feedback of the op amp. So this output is indirectly driving the both the inputs of the op amp, and it changes how and it depends on the feedback circuit how greater the drive strength is on greater the impact of V0, the output is on the positive terminal and the negative terminal. Of course, we might have we have independent sources, some current sources or some voltage sources biasing the op amp and the linear circuit in the feedback we have. So we will see how it is done. So now we know that in feedback, it as a term itself suggests, we are only concerned about what part of V naught, the output voltage of the op amp, is going back to the inputs of the op amp. So we will not be considering the voltage sources or the current sources which are used for biasing the circuit. We will not be considering that. We will be only concerned about what part of output voltage is driving the both the terminals of the op amp, and that is how we would be deciding in what feedback configuration the op amp is. So I have written a linear equation which for VAB is VA minus VB. So it is some alpha times, I'm using some coefficient, some alpha times V test, so output voltage. So the reason I'm using V test here is we are ignoring all of the like the models and the whatever the circuit is inside the op amp, and we are simply trying to see what part of V test goes into VA terminal VA and terminal VB. So that way we would be deciding if the op amp is in positive or negative feedback. So I'm using alpha times V test. Some part of V test would be coming to VAB, and some part of V1. So V1 I'm consider in support in meaning we might have different sources, so beta 1 v1, beta 2 v2, subsequently, and some current sources we have, which is alpha gamma times gamma 1 I1, gamma 2 I2, and some linear combination of VAB. So as already mentioned before, we are only concerned about what part of V test, that is the output voltage, is coming back to the inputs of the op amp. So we would be simply ignoring both the independent sources that we have in the circuit. So we would simply short circuit. We How to ignore voltage sources? We simply short circuit it, because in voltage in a what do we say, in a voltage, when voltage is zero, we simply short it. So it is zero potential, the potential difference between the terminals is zero, hence we short it directly. And in current source, when the current is zero, it has infinite resistance, so we simply open circuit it. So that is how it is done. So we simply short circuit the voltage sources, independent voltage sources. If we have dependent voltage sources, then you should calculate the voltage, the potential of the dependent voltage sources. So we might have some VAB, some dependent voltage sources mentioned like this. So you have to calculate VAB, VAB are the terminals of this, not the op amp. So we have to find VAB after doing this, after shorting and opening out the voltage sources and current sources respectively. So then we would calculate the voltage source, the V potential difference of the dependent voltage sources, and then calculate accordingly. For now, for simplicity, I am considering that there are no dependent voltage sources. So let's proceed further. Now, once we ignore these both the independent voltage sources and independent current sources, we are only left with what part of V out V test comes back into VAB. Now, now have to find in VAB in terms of V test. VAB signifies, we already know, VA minus VB, that is positive, the voltage at the positive terminal minus the voltage at the negative terminal, which is signified by VD. VD is difference voltage, or the differential voltage, to be precise. So the K is gain of the op amp. And now when we solve through the linear circuit and find out what VAB are, if we find out that alpha is positive, which means we let me draw it and you'll understand it better. So this is VA, this is VB, and we have some V test. So some part of V test which is affecting the VAB. What was VAB? VAB was VA minus VB. So if VA minus VB is the coefficient of VA minus VB is positive, which means the coefficient alpha is positive, then it is positive feedback. Why it is so? See, in an op amp, if the feedback part is if in some terminal, if we increase it, and the output from the op amp also is trying to increase it, then it is in positive feedback. But when if we apply some stimulus in the upward direction, or we are trying to increase the terminal, and the feedback path is actually trying to decrease the potential at the point we are applying the stimulus, then it is called negative feedback. So when alpha is positive, so what does this signify? When alpha is positive, this means the potential, the difference voltage VAB is it is positive. So when we are trying to increase V test, so we apply a positive stimulus at V test. V test is positive. When we are trying to increase it, the potential is the part of V test is going and actually increasing VAB. So what happens when we increase VAB? VAB, when it increases, it multiplies by the gain of the amplifier, gain times VAB. When we are trying to increase V test, that it is in turn going and increasing VAB, which will in turn increase V0, and this loop will follow, and the output voltage will finally settle to either VDD or VSS in case of how we are applying. Okay, so it is clear that when alpha is positive, it is positive feedback. When alpha is negative, when we apply a positive stimulus, what does it mean that alpha is negative? When we apply a stimulus at v naught, so as like in this case v test, when we apply a stimulus at v test, the linear circuit, the feedback part is going and actually trying to decrease the VAB is VD, differential voltage of VAB. So what does happen? See, V out, V naught or V test here is equals to some gain A or K, whatever you take. Some V naught is equals to some K times VD, difference voltage. When you are increasing V naught, the feedback part is actually trying to decrease VD. So what does it mean? Alpha is negative, then it is trying to decrease VD. Okay, so in this way we can find if the configuration is positive feedback or a negative feedback. This is a generalized mathematical way. In a subsequent video we will learn it deeply with an example, and also try both positive and negative feedback cases, and how the output is depending on how the output or the working of the op amp is getting affected when it is connected in positive feedback or negative feedback. Thank you.